part 3 of electrolysis, which is the ionic half equations. So we're looking at the ionic half equations for the reactions that is taking place at the cathode and the reaction that is taking place at the anode. So for this singular reason, we will look at the equation, the half equations, as they do take place in the anode and in the cathode. You know, this aspect of chemistry has something to do with what we call electrochemistry. The reason why we call it electrochemistry is that electrons are moving from one place to another in the entire system, and as this electron moves, they have to dissociate the ions that are found in the compound or in the solution, which is called the electrolyte. So these ions disintegrate these electrons helps to disintegrate, or the flow of current helps to disintegrate the ions that are found in the compound, or makes the compounds to get ionized. So these ions now migrate to their oppositely charged electrodes. So for the positive ions, they migrate to the negative electrode, which is called the cathode. And for negative ions, they migrate to the positively charged electrode, which is called the anode. So the equations that is taking place, the chemistry of equation, or this aspect of chemistry is first of all called electrochemistry. Now today we're going to be concerned with the equations that do take place in this regard. Okay, in this aspect, when we start to talk about electrolysis or electrochemistry, here we will be talking about, we'll be looking at other very similar reactions that we know before, called the oxidation and reduction. Now, here we will not be defining oxidation and reduction in terms of the additions and removal of oxygen. We will be defining oxidation and reduction in this anode and cathode. We'll be defining oxidation and reduction in terms of electron loss or in terms of electron gain. So here we're describing electron loss and electron gains. You know, that's what's singularly or simply happening in this regard. So oxidation is when a substance loses electrons. When a substance loses electrons, then it becomes oxidized. Oxidation is when a substance loses an electron. When a substance loses electron, that substance is said to be oxidized. Reduction is when the substance gain electron. Reduction, on the other hand, is when you gain electron. You know, we've kind of explained this, that when you gain electron, then you have lesser, when you gain electron, you have more electron than proton, right? You have more electron than proton. But when you lost electron, you have less electron than proton in the atom. Okay, so as ion becomes in contact with the electrode, electrons are either lost or they are gained, right? And they form a neutral substance when this happens. When they either when substance lose electrons or gain electrons, then it will form a neutral substance. It will form a neutral substance. Because actually the loss of electron and the gain of electron gives you a stability. For example, you lose electron in order to have your maximum number of electrons to be 8 in the nearest outermost shell. For example, like in case of sodium, if you're looking at sodium, for example, you know the first shell holds a maximum number of 2 electrons, the second shell holds 8 electrons, and the third shell holds 1 electron only. So sodium as a metal needs to lose that 1 electron in the third shell, needs to lose it in order to get stability. So he needs to lose it, and he loses it to chlorine. Chlorine is having 2, 8, 7. 2 in the first shell, 8 in the second shell, and 7 in the last shell. So he needs it to make it complete 8, okay, so that chlorine will also be stable. So we say as the ions, they come in contact with the electrode, the electrons are either lost or they gain. And when this happens, they form neutral substance. They form neutral substance. They no longer become ionic substance. When they lose electron or they gain electron, they form neutral substance. They no longer become ionic substance. They no longer become ionic substance. Ionic substance. Okay. Now, these are then discharged as products at the electrode. The neutral substance will now be discharged as products, like what is produced from the electrolysis process. So they are discharged as products, okay? Whatever the neutral atoms or the neutral elements or whatever, or neutral gases, whatever is then found is discharged as the product. Now at the anode, a negatively charged ions lose electrons and they oxidize. You know, when you lose electrons, you become oxidized. A negatively charged ions at the anode. You know, anode is a positive electrode, and it's negatively charged ions migrated to it, so they will lose electron. The negatively charged ions will lose electron, and they will become oxidized. At the cathode, a positively charged ions, they will gain electrons, and then they will become reduced. They will gain electrons, and they will become reduced. We're going to see this with equations. We're going to see this with the equation. Then the ionic half equations shows the oxidations and the reductions of the ions involved in each of them. So it means at the anode, oxidation takes place at the anode. Oxidation takes place at the anode. Why? Because the negatively charged ion, they lose their electrons at the anode. They become what? They become oxidized. They become oxidized. At the cathode, which is a negative electrode, the positively charged ion, they gain electrons and then they become reduced. So reduction takes place at the cathode. Take note, okay? Reduction takes place at the cathode. Now let's take a look at the equations. What happens? It is important for us to make sure that the charges are balanced. You always, in chemistry, balancing of equation is very necessary. So it is very important for us to ensure and to make sure that the charges are balanced. Now let's take a look at the table of reduction and oxidation reactions at the electrodes. We have the multi-lead bromide, the electrolysis of multi-lead bromide. At the anode, what happens? At the anode, what takes place? At the anode, what happens at the anode? At the anode, what takes place? The multi-lead bromide, electrolysis of multi-lead bromide. At the anode, we say, sorry for that 1 minute interruption. We say at the anode, the negatively charged ions, they will lose their electron. The bromine is the negatively charged ion in this regard, okay? Because remember, when electricity passes through this lead bromide, it will ionize it to bromine ion, and lead ion. Lead 2 plus, Pb 2 plus, like let's show that. So lead bromide, okay, let's take a look at the lead bromide, Pb. Okay, lead bromide will be, when you pass electricity through it, it will ionize it to these ions, lead and bromine minus. So we can balance it by making it 2 at the back. Okay. So electricity will break this one into this one, and this one. So you see, this is now, so this one will migrate to the, this is a positive ion, it will migrate to the cathode, to migrate to the cathode, right? This one will migrate to the cathode, and this one will migrate to the anode. Okay, so we say this one will lose electron. The negatively charged, this one will lose electron. You know why? Because electron is already coming from the battery. You know, the battery side, okay, you have your solution here. You have your solution, multi-lead bromide, sorry. You have your multi-lead bromide here. You have your multi-lead bromide everywhere here. So this one will migrate to the, okay, now the way we drew this is the negative electrode. Okay, the negative electrode is the PB, that is this one that will be here now. So the way we drew it, based on our drawing, this PB will be on the other side. Okay, here you have bromine now, bromine ion. Okay, what it means is they will migrate here, they will be here. Bromine ion will be here, right? Bromine ion, the minus. Bromine ion. They will migrate here. So where's the positive? This is the anode. This is the anode. And this is the cathode. This is the cathode. Okay, so at the cathode here, you have lead, Pb2+. Okay, Pb2+ will be here. They will migrate here. So what happens is that, now let's take a look at the equations. This one will lose electron because this one will, at the cathode, this one will lose electron. Let's take a look at this. We say at the cathode, the positively charged ion, they will gain electron. At the anode, the negatively charged ions, at the anode, the negatively charged ion will lose electron. So at the anode, let's take a look at the anode first, anode equation or anode reaction. At the anode, the negatively charged ion will lose electrons. So let's write the equation at the anode. The page is finished? Okay, so let's take a look at the anode. We say the negatively charged ion, at the anode, the negatively charged ion will lose electron. So at the anode, the negatively charged ion will lose electron. See, the other board is better. The negatively charged ion will lose an electron. So we have bromine. Ion will lose electron and become a bromine molecule. And become what? A bromine molecule. And become a bromine molecule. So at the anode, this negatively charged ion will lose the electron. We lose the electron and become a bromine molecule. So that's what's happening at the anode. Is that okay? So we say the negatively charged ion, they will lose electron and become a bromine molecule. This is a bromine molecule with 2 atoms. This is a bromine molecule with 2 atoms. Now at the cathode, the positively charged ion, they will gain electron. That's why you see they gain electron. That's why it's having +2 here. Here they lose electron. Here they lose electron. Because if you bring this one, if you bring this +2 to this side, you see that is a loss. It's lost. It's like if you make the equation, if you decide to make this equation like this, you will see that they actually lost electron. See, if I write like this one will be -2e, -2e. Okay? For those of you who don't see it, why is the equation like this? This will be equal to what? This will be equal to bromine molecule. This will be equal to bromine molecule. Okay, you see? What I just did here was to, like, assuming I'm making the bromine molecule the subject of formula. I move this one here, you see? At the anode, we say the bromine ion, they lose electron. They lose. Minus like they lost. This negative is like lost. It's like lost. So they lose electron. But the way we write it, this is how we write it in there. There's the standard format for writing it. Okay? This is the standard format for writing it. So at the anode, the bromine ion, they lose electron and become bromine molecule, which you can also call a bromine gas. Okay? Which you can also call bromine gas. Now let's take a look at the cathode. At the cathode, the negative electrode. The negative electrode. What happens at the negative electrode? Okay? Let's find out what happens at the negative electrode. Now, at the cathode, what happens? The lead, the positive ions, which is the lead Pb2+, this one, they will gain electron. Right? They gain electrons. They gain electron. See the equation at the cathode. They gain electron and become lead solid. Become what? Lead solid. Okay? Become lead solid. Okay, so this is what happens. This at the cathode, the lead, the positive ion, they gain electron. They become lead solid. At the anode, the negative ion, they lose electron and they become a molecule. Now this is for electrolysis of multi-lead bromide. What of electrolysis of concentrated aqueous sodium chloride? Remember concentrated sodium chloride? We have chlorine at the anode. The chlorine ion will lose electron and become chlorine molecule. They will lose electron and become chlorine ion will lose electrons and become chlorine molecules. Okay? Chlorine, I say if you want to know that English lose electron, you bring this 2e. If you bring it to this side, become minus 2e. So they lose 2 electrons and become a chlorine molecule. Then at the cathode, the hydrogen, you know, is hydrogen. We've already explained which one goes. Hydrogen goes, not the sodium. We've given reasons. We showed you in the reactivity series, the one that is less reactive is the one that will migrate, the metal that will migrate in the reactivity series. Although hydrogen is not a metal, but it behaves like one sometimes. So hydrogen will migrate instead of sodium, so not the sodium. So the sodium ion at the cathode, the sodium ion gain 2 electrons and become the hydrogen ion gain 2 electrons and become hydrogen molecule or hydrogen gas. Is that okay? Then what of electrolysis of dilute? When there's dilute, we say anytime there's dilute, it is not the halide that we go for the anode. It's not the halide. Once you have dilute, meaning the thing is soaked with a lot of water, there's water molecules. Okay, so OH ion will be the one that will move, so it will produce oxygen gas. Okay, remember we've explained this concept. It's not I'm repeating it again, no. So I'm just reminding you. So we say when there is a dilute sulfuric acid or dilute solution or aqueous solution, whether you hear dilute or aqueous solution, most times it is this one that goes. It is the OH ion that goes, that migrates to the anode, okay, anode electrode, the positive electrode. Now this OH ion, when it migrates there, it produces oxygen gas. Produce oxygen gas and water. Produce oxygen gas and water plus 4 electrons. So it loses 4 electrons and produce both oxygen gas and water. Is that okay? Please take note of this equation. It's very easy to write. For dilute, when you see dilute sulfuric acid, you know sulfuric acid is H2SO4. Okay, H2SO4. So the ions that go is not the SO4 ion, it's the OH ion, because this is dissolving water. There's a lot of water. There's water ion, the hydrogen ion, and the OH ion. So the OH ion moves here, migrates here, and they lose electrons to form oxygen gas, to produce oxygen gas and water. Is that okay? At the anode, it's the same hydrogen that will go, because here is only option of hydrogen, H2SO4. Okay, it's only hydrogen ion. So hydrogen ion will go. It will gain 2 electrons to become a hydrogen molecule at the cathode. So I hope we get this concept and so on and so forth. Now let's go to the application of electrolysis. Before then, let me quickly say something that to help you remember the definition of oxidation and reduction, you use what we call the oil ring. Okay, you use what we call the oil ring. You use what we call the oil ring. Oil means oxidation is the loss of electron, and reduction is the gain of electrons. When you are doing electrolysis, use the term oil ring to remember the definition of oxidation and reduction. Okay, now let's go to the application of electrolysis. What we use it for, or how it finds is what we use electrolysis for, or the usefulness that comes with electrolysis by us doing this process of electrolysis. Number one is electroplating. Number one is electroplating. Number one is what? Electroplating. We say electroplating is a process where the surface of one metal is coated with a layer of a different metal. Electroplating is just a process whereby the surface of one metal is coated or is covered with the layer of another metal, with a different metal. Okay, the surface is covered with the layer of another metal. Now, the anode is made from pure metals. You want to coat with objects, with your object, with any object of your choice that you want to cover it up with. Okay? The cathode is the object to be electroplated. Okay, the cathode is the object that we want to electroplate in this regard. Okay? So since the cathode is the one we want to electroplate, is the one we're going to cover with another metal. The electrolyte is an aqueous solution of soluble salts of pure metals at the anode. The electrolyte is an aqueous solution of soluble salt of pure metal at the anode. Example, let's take a look at an example. Coating a strip of iron metal with tin. We want to coat a strip of iron metal with steel. Now look at the strip of iron metal, this one. This is a strip of iron metal, this one. This is a strip of tin metal. This is a strip of tin metal. And we want to cover this one with tin. This is tin atom deposited here. Okay, tin atom deposited here. So we have, if we want to do that, we have to use a tin chloride as our solution, so that when it dissociates, when this tin chloride dissociates, it will break into ions such as tin ion and chlorine ion. The tin ion will migrate to the, you know, it's a positive ion. The tin is a positive ion. It will migrate to the negative electrode. To migrate to the negative electrode, while the chlorine ion will migrate to the positive electrode. So you can see one application of it. The tin, when it migrates to the negative electrode, remember the negative electrode is an iron metal. So the tin will cover the surface. We cover the surface of the iron metal. This is the iron metal. The tin, you know, the tin migrates here and cover up the surface. So that's one application of electrolysis for electroplating. Now, this is a piece of iron being electroplated with tin. The electrolyte is tin 2-chloride, a water-soluble salt of tin. Now, what happens at the anode is that at the anode, the tin atoms lose electrons to form the tin ion in solution. Then at the cathode, the ions gains electron to form a tin atom which deposit on the strip of iron metal, coating it up with a layer of tin. So that's what happens. Okay? That's what happens. Now let's look at the cathode. Look at the cathode. This is the cathode. The one connected to the negative side of the battery is called the cathode. So we say at the cathode, the thin ions, they gain electrons, right? At the cathode, the thin ion, they gain electrons to form the tin atoms, which are then deposited at this to cover as a strip to cover the iron metal, to cover the iron metal. What happens here is that the tin, they gain electron, the tin ions, they gain electron to become tin metal, Okay, the tin metal now covers up this negative electrode. Now cover this iron negative electrode. Is that okay? Now let's go to uses of electroplating. What can we use electroplating to do? Why do we electroplate? What benefit is in there for electroplating substances or substances that will be electroplated? What benefit do we have in them? So electroplating is done to make metals more resistant to corrosion. The reason is to prevent rusting, to make metal more resistant to corrosion or damage, or to prevent metal from easily be damaged by water or by air or mixture of water and air that can cause rusty and that can cause corrosion to happen to the metal. E.g. chromium and nickel plating. We use chromium to plate and we use nickel to plate. Then another use of electroplating is that it's also done to improve the appearance of metals. So metals, their look is not good. So you electroplate them to improve their appearance. You electroplate them to improve their appearance. Is that okay? Okay. So these are the equations for tin at the anode and at the cathode. Okay? So at the cathode, they gain electrons and become a tin solid. At the anode, they lose electron to become ion. They lose electron to become ion. So that's what is happening. Now let's go to the next section. No, 4.2.2 is hydrogen fuel cells. Okay, electrolysis helps us to produce hydrogen. You know, you can see that at the cathode, hydrogen is always produced. Hydrogen gas is always produced. Now, this hydrogen gas, it's used as fuel cell. It's used as fuel for many cells. Okay, a fuel is a substance which releases energy when it's burnt. A fuel is anything that releases energy when it's burnt. So hydrogen is capable of doing that. Petrol, kerosene, all this fuel, gasoline, they are capable of doing that. Is that okay? they release energy when you burn them. They burn a lot. They release heat energy. That means they can burn anything. Like firewood is a source of fuel. You can fetch firewood, dry woods, and put them together, light them up, and they will start to burn. They can even help you to cook food. You can even get the charcoal from there and use the charcoal to do other things. So anything that releases energy, during burning, they release heat energy. Remember, energy is not just one thing. It could be thermal energy, heat energy, light energy, whatever kinds of energy. Anything that when it burns, it releases energy is regarded as fuel. Hydrogen is used as fuel in rocket engines, and also in fuel cells to power some cars. They are used as fuel cells to power cars, also used as fuel in rocket engines. So production of hydrogen is very vital for rockets, and it's also very vital for cars nowadays. So a fuel cell is an electrochemical cell in which fuel donates electrons to the electrode and oxygen gain electrons at the other electrode. So that's a fuel cell. That's what happens. We say that fuel will donate electrons at one electrode. One of the, we have cathode electrode or anode electrode. At one of the electrodes, the fuel will donate electrons, will give electrons. And oxygen will gain electron at the other electrode. That's why it's burning. That's why it burns. Oxygen is gaining electrons at the other electrode to keep burning. Okay? Now, the hydrogen-oxygen fuel cell produced electricity by combining both elements and releasing energy and water. They will release energy and they will release water. They will produce electricity. Okay? The overall equations for the reactions with the hydrogen fuel cell is the reaction of hydrogen plus oxygen to produce water. Okay? Now, meaning the hydrogen burns the presence of oxygen to produce water. Now, this burning is what is called the process of being fuel. Is the process of being fuel. Anything that burns to release energy is fuel. Okay? So the diagram we're about to show shows the setup of the hydrogen fuel cells. Okay? Now, the air entry provides the oxygen. You see, you have air in from one side. You have air in. This provides the oxygen. So when air goes in, it provides the oxygen. The fuel entry provides the hydrogen. Here, the other side, on the left, fuel is entry. That means hydrogen is entry. Because in this case, hydrogen is the fuel. So it provides the hydrogen. Then this hydrogen will diffuse in, and this oxygen also goes in, diffuse in, and then they react together, they bond. They bond. So when there's excess fuel and water, they go out from here. Excess fuel and water, they go out from here. So here is the anode, and here is the cathode. Okay? At the cathode, okay, here is where you have the electrolyte. So at the end of the day, what is produced? Hydrogen bonds with oxygen to produce energy, okay, to power the car, to produce energy that drives the car. So this is the display. This is the display. Is that okay? Now let's go to the advantages and disadvantages of hydrogen fuel cells. Hydrogen oxygen fuel cells are becoming very, very common nowadays in our automotive industries to replace the petrol and diesel that we are very used to. So nowadays we're producing the hydrogen oxygen fuel cells because this petrol, diesel is a big issue for many countries that don't have petrol. It's a big issue and it's a big cost for many countries that don't have oil and gas. Now let's go to the advantages. One of the advantages is that they do not produce any pollution. They are clean energy. They don't produce pollution. Remember, they produce water and energy. They don't produce pollution. So the only product is water. Whereby petrol energy, they produce carbon dioxide They produce oxides of nitrogen and so on and so forth, which causes air pollution in our environment. So the hydrogen oxygen fuel cells, they produce what we call clean energy. They produce water as their product, so they do not pollute the environment. Another advantage is that they release more energy per kilogram when compared to petrol and diesel. They produce more energy per kilogram when you compare them to petrol and diesel. That's another advantage. More energy is produced per kg. Now, another advantage is that no power is lost in transmission, as there is no moving part. No moving part in this one. No power is lost. Unlike internal combustion engine of vehicles when you use petrol and diesels. Then there are quite so less noise pollution compared to petrol engines. The engines from here, they have less noise. The cars are quieter. When they move, you don't hear their sound. Or like when you're using the petrol or diesel car, they vroom, 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 they make a lot of noise. So these are 4 advantages the hydrogen oxygen fuel cells has over the normal diesel. But they also they don't come without disadvantage. Their disadvantage includes, but not limited to, only that the material used in producing these fuel cells are super expensive. The materials that we use, or the materials that are used to produce, I can't hear. Okay, the materials that are used to produce these hydrogen oxygen fuel cells are super expensive. Then another disadvantage is that hydrogen is more difficult and expensive to store compared to petrol, and it's very flammable. It burns readily, so it's very flammable, and it can easily explode when it's under pressure. When there's high pressure, it can easily explode. So for that reason, it becomes a big disadvantage. Expensive to store and very flammable. Hydrogen is very flammable, you know this. Then another disadvantage is that fuel cells are affected by low temperature, becoming less efficient. When there's low temperature, like all those cold winter period, then they will be affected. And they will become less efficient. Another disadvantage is that there are only a small number of hydrogen filling stations across any countries right now. We don't have many hydrogen filling stations. So such that when your hydrogen is getting finished or is reduced, you stop in the filling station and fill up your hydrogen in your car. So there are very less hydrogen filling stations. So this becomes a disadvantage. For now, this is a problem that will be solved by itself as more and more hydrogen filling stations are built across countries. The another disadvantage is hydrogen is often obtained by methods that involves the combustion of fossil fuel. In one of the methods, we get hydrogen. We have to pollute the environment first, like by burning fossil fuel in order for hydrogen to be produced. So when this happens, then the carbon dioxide and other pollutants, they pollute the environment. Is that okay? So so that's the end of electrolysis. We've rounded up electrolysis. Our next chapter will be chemical energetic, which we will take hopefully by the following day. Okay, so I think we stop here today, okay?